Okay, today, it's kind of a big, wide-ranging review. So this is the part where cell phones go away and you follow along with a quick review of everything that we've done for this chapter so far. All right. So first off, solving these questions really boils down to finding the x, which is in the exponent. Here's one that would be pretty easy. Not even R2 on the test, it's just too easy. But it has an x in the exponent, so it's called an exponential. Right away, I hope you just either guessed and checked and went, oh, it's got to be 2, because 5 squared is 25. Or you could have gone like, okay, I know he wants me to get the bases the same, so I'll do that. That way this equals this. Either way, the answer is 2. Raise your hand if you had that answer. Okay, awesome. Then what if it gets more complicated, like 4 to the 2x equals 1/4 to the x plus 1. Do those have the same base right this second? No, they do not. If you make them so they do have the same base, here and here, then your life will be a lot easier, because then you can just look at the exponents, and there'll be an equation created by the exponents. So then it boils down to you understanding negative exponents. Do you, sir, know how to make that 1/4 into 4 to a power? That's correct. That's it. This side doesn't need to change at all, but this side's going to change into 4 to the negative 1 to the x plus 1. How many of you actually knew that one? Okay, good. That's an important one to know, how the negative 1 makes a fraction out of the 4. Okay, so then do you get, I had to make something exactly equal here and here. You can't do a substitution unless it's equal. If you guys are playing cards and there was like, I don't know, you're playing a game, there's some money in the middle, or let's say that there's even just candy bars in the middle, you've like playing with fun-sized candy bars. I've done that before. It makes a fun way to play poker. All right, so then if you pull out like a Snickers bar and you put in like a penny, is that a fair trade? No, that's not a fair trade. People would be like, no, I'm not letting you switch that out of the middle. You know, like it's got to keep it fair. Okay, so if you pulled out a Snickers bar and you put in like 75 cents, people might be like, okay, that's fair. That's about what they're worth. Okay. All right, so you have to you have to replace these things and substitute things that are equal. Then this part is equal to this part. So 2x is equal to, this is a common mistake right here, negative x plus 1. I see that all the time. Do you know what went wrong? It's negative x minus 1. Because that negative should have got distributed. This should be negative x minus 1. Watch out for that. I'm telling you, that is the most common mistake in this unit, is forgetting to distribute that right there. Now, I'm not saying there aren't a lot of other mistakes people make, but that's the most common one. All right, and from here, it's easy to solve. I get rid of the smaller of the two x's. So I'm adding x to both sides. And then I just have to divide by 3. And my final answer is x equals negative 1/3. Raise your hand if you had negative 1/3. Okay, awesome. That's kind of the, like, second level. Third level question. What if it's got a fraction like 2/3 to the x plus 1? And then another fraction which you can tell is related, but it's flipped over. So I'm going to go with 9/4 to the 2x. Now, do those have the same base right this second? No, they do not. Make it so they have the same base, and then solve it. Now, I'm going to give you 2 questions to work on in a little bit of time. Try that one, and then try to solve this one. I'll put it on the same screen here. 3rd root of n plus 1 plus 7 on the outside is equal to 10. Try the red one and the black one. I'm going to pause for a minute while you give those a try. Okay, remember, we don't have a test on this until next week on Thursday. A little less than 1 week, but still quite a ways from today. All right, so first, this kind is usually the most troubling for people because they're trying to figure out how is that and that going to be able to be equal. I recommend you do this. Once you suspect that the smaller of the two numbers might be the base you want, then you write that here, even if it isn't true. I know 2/3 isn't 9/4. You write it there with a question mark, and you try to think of what power would work. And then I got to put to the 2x. And then I want it to be 2/3, so what power would work right there? And somebody must know it. What is it? Do you get you have to square 2/3 and it'll turn into 4/9? And then it's upside down. So it isn't just 2, it's -2. How many of you knew that it was a -2 right there? Okay, good. All right, so then that is equal to that. X plus 1 is -2 times 2 makes -4x. And then I can get rid of the smaller one. Don't be afraid of 0. A lot of people think, I can't do this, so there'll be nothing on that side. Yeah, there'll be 0 on that side, and it's totally okay. 5x plus 1 equals 0. So 5x equals -1. So x equals -1/5. And there you go. Raise your hand if you had that one right. That was only about half the room. We'll try another one like that in a second. Over to this one. On here, I'm hoping you knew that you subtract 7. You always look to add or subtract first, and we could this time. Then, I like to save a whole step by just, when I bring this down, I bring it down as n plus 1 to the 1/3. I didn't change anything except how I wrote it. Because this is equal to this, and that's called substitution. I substituted the one for the other. They're equal. And the other one with the 1/3, this new one, that's better because then I can just put it to the power of 3. 1/3 to the power of 3, these get multiplied, and I now have n plus 1 equals 3 to the 3rd is 27. And then some people might be like, well, Server, you always told us to do it in the order where like you add or subtract first, and yet you're subtracting last. Why am I subtracting last? Because I'm doing a parenthesis. I'm doing the parenthesis last. You do the add, subtract first, then the multiplies, divides, then the exponents, and then you do the parentheses last. This is when you're solving equations. You do the reverse order of operations. And that's the reason I'm doing this last is because it's a parenthesis. So, final answer, n equals 26. How many had that one right? That's almost everybody. Excellent. Then we should practice this kind with the weird fraction. We should do one more like that. So let's say I had 3/4 to the x plus 1 is equal to 64 over 27 to the 2x. So what's tricky is making it so that they have the same base. This and this got to be written with the same base. Now, two little factoids that you need to know. 4 to the 3rd, who's got that memorized? 4 to the 3rd is what? 64. Good, you need to know that. And 3 to the 3rd is what? 27. And 5 to the 3rd is 125. Those are the toughest to the 3rd powers that we expect you to know. We don't expect you to know 6 to the 3rd. 5 to the 3rd is the highest we go. Now, 2 of the 3 of those are useful right now. All right, I'm going to pause for a second while you try to finish this one. And I hope you saw that this really needed to be 3/4. So I'm going to try to bring this down and see if I can make it work. 3/4 to the x plus 1 there. And then here, I want it to be 3/4, so I put 3/4 to the I don't know what. And it's also to the 2x. So it really comes down to this little spot right here. Did you figure out what it needs to be? Raise your hand if you figured out what it needed to be. over in the back. Yes. And you cubed them all. I bet you what your brain did first was you figured out that, oh, I got to put them all to the third, hint right here. But then 3 wasn't going to do it because it'd be 27 over 64, and you realized -3 would work. Okay. Now, this must be equal to that. And you have x plus 1 equals -6x. You get rid of the smaller one. Now, there is 2 ways you could do this one. I would be totally okay with, in this case, you subtracting x from both sides, just because it's going to be just as fast. X equals -1/7. Raise your hand if you had that one right. Okay, awesome. Then we're kind of all caught up to today, and here's the new stuff for today. And again, like I'm going to see, it's only going to take like 2 minutes to show you this. Do you get if you had a to the 5th to the 2nd? Some kids are going to say that's a to the 7th, and some kids are going to say it's a to the 10th. There's usually nobody who thinks it's a to the 3rd, but that'd be another option. Okay, which one is it then? So here's my advice to you. If you are ever stumped, write out what it really means. That's what a to the 5th really means. And if you look at that, I doubt anybody in here is going to think, oh yeah, that's a to the 7th. You're going to realize that's 2 sets of 5 a's. So that is a to the 10th. So don't just like flip a coin. Write out what it really means. All right, here's another example of that. Oh, final answer, a to the 10th. Let's say I had a to the 3rd over a to the 2nd. If you're not sure if it's like a to the -1 or a to the 1 or 1 over a, write out what it really means. A over a. Cancel, cancel. It's just an a on the top. That's just a in my book. Couldn't I have just subtracted these? Yes, you could have subtracted those. Okay, so here's why you care about those old rules right now. Oh wait, one more kind. A to the 5th times a to the 2nd. And I totally get you might be flipping a coin between adding them or multiplying them. Please write out what it really means. I call it exploded view. Somebody like, well, I know what to do. Just write it out. Nobody would look at that and think that it's a to the 10th. It's a whole bunch of times, right? Times, and that must be a to the 7th. So yeah, you add that kind. So it's just a good reminder for you that when you're stumped on these exponent ones, to write them out at exploded view like this, and you'll get what you're really doing. So here's a typical homework question then. A to the 3rd over a to the n is equal to a to the 4th. And then they say solve for n. All right. Do you remember how our whole theme was make the bases the same? Do you get the base is kind of a, but there's 2 of them over here? Would you agree that I could make that down to just 1a if I do the right things to the powers? This just comes straight down. Can you tell me what this should be? A to the what? What do you do when they're dividing like that? Do you add the powers, subtract the powers, multiply the powers, or divide the powers? Subtract them. So that's a to the 3 minus n. Do you remember me saying that when the bases were the same, this had to equal this? 3 minus n equals 4. I bet you anything you can solve this one. Raise your hand if you had n equals -1. Okay, good. One last one. A to the n times a to the 5 is equal to a to the 14th. Use what I've been telling you about getting the same base and solve. All right, so on this one, we're going to go a, we got to get it down to just one a, so the bases are the same, right? To the n plus 5 is equal to a to the 14. Do you get that these guys are equal, and the a's just kind of drop out? We don't care about the a, we're solving for n. All right, so final answer. N equals 9. Raise your hand if you had n equals 9. Okay, awesome. Then there's one more that kind of bends people's brains on the Schoology quiz, and I want to talk about it ahead of time so it doesn't hurt you too bad. And they said solve for x. It's not exactly this, but it's like this. N to the x plus 4 is equal to n to the a. Solve for x. Take your best guess. Take your best shot at it. And usually, the people that are having a trouble are making an assumption that is not true. I'll tell you what that assumption is. If you think you can't do it, you're making an assumption. Okay, would you agree the bases are the same? So then this must be true. X plus 4 is equal to a. And then you're like, how are you supposed to solve for x? Well, get x alone, and the answer is just x equals a minus 4. The assumption is kids think you can't have a variable in the answer. You can totally have a variable in the answer. There's no reason I can't have an a in my answer, as long as you solve for x. Do you get, with the same exact problem, I could have said solve for a, and then I'm almost done here. I could just add 4 to both sides, and I'd have x plus 4 is a. A is x plus 4. So if you solve for something, that doesn't necessarily mean the answer is always just like 6. You're in higher algebra now, so there's oftentimes variables in your answer. Okay, I think that's enough. I think you're going to rock the Schoology quiz. And why don't we have you guys pull up the Schoology quiz and tell me the first couple questions, and I will verify the first couple answers, because once you're started, you're halfway done. Would you read me question 1, please, Miss W?
Use the properties of exponents to solve for x. 4x times
4 to the x?
Yeah, 4 to the x times 4 squared equals 4 to the 5th.
Why can't I just do it the way it is? It's got 2 bases on one side. So these have to get mushed together to just have one base. So what would it be? 4 to the x plus 2. You just add powers like that. Okay, now this has to equal this. X plus 2 is 5. And if you can't solve that, you're in the wrong class. Okay, moving on to number 2. JS, would you read me number 2?
Use the properties of exponents to solve for x. A squared over a to the x equals a to the negative 3rd.
What's your guess on the approach, Mr. S?
That x is equal to 5.
You just gave me the answer. I want to know what to do.
So I don't really know how to do it.
Oh, I don't really know how to do it is never a good way to start with a math teacher. All right, I know you guessed and checked, but those can be made into 1a. Think about it now. A to the what? A to the 2 minus x. And I know you figured it out in your head. That's great. But when the problem is hard and you can't just do it in your head, you need to know how to set this up. Because we could have made these numbers nasty and the answer could have been like 16.7 and you wouldn't have been able to do it in your head. So that's how you do it You put this and this together as a, when you're dividing them, you subtract the powers. All right, so final answer, 2 minus x is equal to negative 3. Subtract 2, subtract 2. Negative x is equal to negative 5. X is equal to 5. And if my life depended on it, I'd check it. I'd go put a 5 in here. If I put a 5 right there, oh, you were right in the first place. 2 minus 5 would give me negative 3, so yay. Now I know you're right, but now you know how to do it. Okay, that was good for number 2. Now I might have to stop somewhere, but I'll just do one more. But I know number 4 might be hard. You can always ask me for help. So, Mr. G, would you read me number 3? Yep.
Use properties of exponents to solve for x. X to the negative 1 equals 1/4.
So easy. What do you do to both sides? And you'll have x alone. Know what to do? Really, it's a one-stepper. You can do this. You just want to get x alone.
Square it.
Interesting.
I don't know.
Wow. You're not wrong. Squaring it would work, but I totally didn't expect you to say that. Squaring it would work. You just have to do one more step. So, all right.
I just wrote that it's 4.
Ah, you just did it in your head again. Okay, so watch. If I put a negative 1 right there, do you get if I do that to both sides? That'll make x to the positive 1. And then I know the answer is what you said. 1/4 to the negative 1 is 4. But that's how you do it. This is giving me a window into how you guys think. And you guys often are just thinking, what number would work? There it is. I'll put it in. But the scary part is when the numbers get hard on the test, that won't work for you. Okay. So, if you get stuck, you can always ask me for help. And I think we did such a wide-ranging review this time. All we have left is just a little bit of that stuff where we give you a situation and you write the equation for it. Like, for example, I just want this to be in your subconscious. If we have 2,000 moose and they're decaying in population by 7%, then how many years, x is the years, would it take for it to get down to 1,000 moose? That would be a typical word problem. And you got to know this is where your starting is. This is where your end is. This is whether it's growth or decay. And that's your rate. And that's your time. Now that's just the rough outline. But now we've talked a little bit about everything that's on the test. And the test isn't until Thursday. So we got 2 days to handle application type questions. Then Wednesday we do review, Thursday test. That's what it's looking like at this point anyways. Okay, that's all I got for you for today.